Right, so for this question, you are proving an identity. Right, so whenever you have to prove an identity, that means you want to make the one side look like the other side. Okay, so you're gonna pick one of your sides, manipulate it, and make it look like the other side, or sometimes you can even maybe manipulate both sides to make them look like each other. But for this one, let's just use this left hand side and let's try and get it to look like the right hand side. So we'll always start with the left hand side. Okay, LHS, just to say that okay, this is the side that you're working with, or you can sometimes use your right hand side if that's what you want to work with. The first thing that I'm going to do here is I see tan, and generally when you see tan you want to change tan, especially if I look at my right hand side. When I look over there, there's no tan there. So I'm clearly going to need to get rid of tan. But we know our quotient identity, which tells us that tan could be rewritten as sine theta over cos theta. Right? So that is sine. Okay. So this is the tan. Okay, great. Now we have a negative and we have cos theta. Divide that with sine of theta. All right, so now what you have is you have a fraction minus a fraction. Hopefully you remember how to add and subtract fractions. In order to add and subtract fractions, we need the denominators to be the same. So we are going to multiply the side over here with sine. Okay, let's just write that again with sine theta on top and at the bottom, and this fraction on the right hand side we're going to multiply this with cos theta. Cos theta. Okay, so what we did was we multiplied with opposite denominators to get our denominators to be the same, right, to find our lowest common denominator. So now the denominator is going to be cos theta times sine theta, and the numerator is going to be sine times sine is sine squared theta. Your second fraction, your numerator is going to be cos times cos, and that's going to be cos squared theta. All right, so what have we done so far? We replaced tan with sine over cos. Then we had two fractions. We made the fractions, the denominators of the fractions the same. And once we did that, we could add our numerators. All right, so that's what we have. The denominator is the way that we want the denominator to be. The numerator numerator is almost as you want it, right? So we look at that. This is not exactly that, but there's a cos, right? There's a cos squared, so let's leave the cos squared. Let's change the sine squared over here. Now hopefully we remember our square identity, and our square identity, let's maybe write it somewhere at the bottom. Your square identity is sine squared theta plus cos squared theta, and that is equal to 1, right? So now from this square identity we have another two identities that we generate, right? And we get those from taking either sine or cos over, making sine the subject of the formula. So sine theta is going to be alone, so I'll have sine squared theta equals to 1 minus cos squared theta. So I'm going to go back to the question above, and sorry, where I have sine squared theta, I'm going to replace it with 1 minus cos squared theta. So let's go up here again. The sine squared theta, which we have here, we're replacing it with 1 minus cos squared theta. Okay, so we have 1 minus cos squared theta, and then we're going to have the spot must still be there, so we're going to have minus cos squared theta. Denominator didn't change. Denominator is cos theta times sine theta. All right, great. So now we look into our numerator, and what we notice there is they are like terms. So this one and this one are like, right? So the 1 on the numerator stays a 1. Then you have minus cos squared theta, minus cos squared theta. So it's going to be minus 2 cos squared theta. And all of this we're dividing. The denominator hasn't changed. Cos theta sine theta. Let's have a look at what we want. Well, that is exactly what we want. That is our right hand side. Alright, so there we have proved the identity. What did we do? We changed tan, then we had two fractions, so we had to subtract the fractions. We got the denominators the same. Once the denominators were the same, we could add the numerators. The numerator, we changed sine squared theta with our square identity, and the rest of that was simplification. Okay, so maybe whenever you deal with a question like this, if you have a tan, you generally want to change tan. If you have two terms, right, two fractions, or and you want to get them to become one term, you get your denominators the same, and then you can add your numerators, and then you try and see where you can fit your identities. At grade 11 level, there's only two identities that you're going to use. It's either the square identity or the quotient identity. Quotient identity is tan theta equals sine. Okay, let's do that again. Equals sine theta over cos theta. So it's either this one that you're going to use, or you're going to use sine squared theta plus cos squared theta, that's a square, equals 1, or this one. And the second one over here, this one has two variations that come from it. Either sine is going to be your subject or cos is going to be your subject. Okay, so we're not going to go into that in this video, but generally same things. You want to change tan. If you see tan, you want to fit your identities where you fit your identities, and then remember how to add fractions and subtract fractions. Get your denominators the same, add and subtract your numerators.